Hello friends, welcome to another cool math video. My name is Ali. Today we are going to talk about divisibility rules by 7. You don't usually see 7 much. Usually it's 2, 3, 5, 6, 10, which is easy. Maybe 11, 9, right? But 7, there is a divisibility rule, which is taught sometimes. Some of you might know. We are going to talk about that. We are going to talk about 2 more different divisibility rules by 7. So in all, 3 different divisibility rules by 7 we are going to go over, and at the end I will try all of them with the same numbers to see, to see how they do comparatively. All right, let's get started. So the one that's known by some of you is probably this one, the first one. I call this Twominus rule. You double the last digit and subtract it from the remaining of the number, and you keep doing that. Even at each step you have one less digit to work with, and gradually you'll have less and less digits, and eventually you'll have 1 or 2 digit number. The original number is a multiple of 7 if and only if that remaining number is a multiple of 7. So let's have a quick test to see how this works with, let's say, a 3-digit number, 184. Wait, that's not a multiple of 7. Let's try 182 instead. So you double the last digit. 2 double is 4. You subtract from the remaining number, you get a 14. At any point, if you recognize a multiple of 7, you can stop. That means your original number was a multiple of 7. All right, so that's the 2-minus rule. Next is what I call the 5+ rule. So it's very similar to the 2-minus rule, but this time you multiply the last digit by 5 and you add to the previous part. So let's see how it works in action with the same number as before, 182. You multiply the last digit 2 by 5, you get a 10, and this time add to the previous part, you get 28, which is a multiple of 7, so we can stop. All right, so next one is a very different one. This reminds me of the divisibility rule by 11, the alternating sum of digits, but this time we have alternating sum of 3-digit blocks of the number. Now, why? For 11 is 1 more than 10, right? So 10 is 1 less than a multiple of 11. That's why in decimal notation, when we write it, odd powers of 10 give remainders that are 1 less than 11, and even powers give 1 more than 11. So that's why we have an alternating sum. This time, 1001, some of you might recognize this, 1001 is a multiple of 7. It's actually 7, 11, 13. So 1000 is 1 less than a multiple of 7, which means we can do something similar, right? So if you have groups of 3 digits, then we'll have powers of 1000 each time. And then odd powers will give remainder 1 less than a multiple of 7, even powers give 1 more, so we will get the same rule. Well, with a 3-digit number, we cannot do much with this. So let's try to see what happens with a 4-digit number. 1, 2, 1, 1. You group the number in blocks of 3 digits. And then you have, so if you want to get the remainder at the end, you want to have the last 3-digit block as a plus sign. And this will be minus 10. So we'll get 2, 1, 1, minus 1, that's 210, a multiple of 7. Hence, 1211 is a multiple of 7. Now let's see how these 3 rules compare to each other with this example. I multiplied a random 5-digit number by 7. I know that this starting number is a multiple of 7. So let's see how different rules will compare. So in the first one, we double the last digit and keep subtracting. 3, so 0 double, that's nothing. So let's double 2, 3, 1, 5, double 5. Then we get 21. At this point, you should probably know that it's a multiple of 7, but even if you want to go one more step, you get 0, a multiple of 7. So it is a multiple of 7. For the next one, we multiply the last digit by 5. So 8 times 5 is usually 40. And this time we add. Times 5, add, times 5, keep adding, times 5, add, you get 70 at the end, which is clearly a multiple of 7, so we can stop. And for the last one, now we are going to group this in blocks of 3 numbers. I'm going to start with the last one is plus and the previous one is minus, etc. It's only 6 digits, so we have only 2 groups. And that's 368 and minus 319. So then we get a 49 at the end, which is a multiple of 7. So the 6-digit number is a multiple of 7. So final thoughts. For me, I love the 1001 rule. And 2minus and 5plus, they are like siblings. They are very close to each other, or cousins. But the 1001 rule, if the number is like 12 digits, you can group in blocks of 3 and, just add or subtract a couple 3-digit numbers, and you'll get it pretty fast. I think it's going to be much faster than the other 2 rules. You can try. Please let me know how you feel, what you think is the best in the comment section. If you like this video, please subscribe for more cool videos like this. Thank you.